this is an interesting integration because you have a product of two cosines. And we don't necessarily know how to deal with a product of two cosines. So if we were to use integration by parts, it wouldn't help because the cosine would turn into a sine and this cosine would turn into a sine, and you would end up in a loop. Also, if you use substitution, this cosine will give you a sine, and that won't cancel with this, and then you have this 7. So it's problematic. But there is an identity that says that a cosine or product of two cosines can be written as a sum and a difference. Okay, so two cosines multiplied can be written as the sum and the difference. So you can write cosine 7x multiplied by cosine x as the cosine of the sum, x plus y, and the cosine of the difference. So that's really convenient. So we can just write this as cosine the sum, so this plus this, that's 7x plus x, plus cosine of the difference, 7x minus x. Okay, so the identity says that if you have twice the cosine of a product, you can write it as the cosine of the sum plus the cosine of the difference. So we didn't have a 2 here. So there's a half missing, a factor of 2 missing. So if you like, we can divide this by 2, and that means we have a half here. Okay, so if there isn't a 2 here, you have to have your 2 here. So let me add a little half there. So I can now write the integration as half the integration of cosine 8x plus cosine 6x dx. And now it's become really easy because we can integrate cosine 8x, we can integrate cosine 6x. So the integration of cosine is sine. So it's half sine 8x over 8 plus sine 6x over 6 plus a constant. And that half, you can multiply denominators. So the final answer will be sine 8x over 16 plus sine 6x over 12 plus a constant.